Hello everyone, we have very exciting progress in AI video recently. Wan 2.1 VACE released the 1.3B and 14B AI models recently. We're not going to limit our video quality by the preview version anymore. I've done several tutorials before talking about Wan VACE, but in this video it's different. As you can see, there's a new update from the Wan video team. The release of Wan VACE, an all-in-one video editing model with the 1.3B and 14B model sizes on Hugging Face, ModelScope, and the official API service endpoint. Sooner, their official video generation site Wan.video will also release VACE into service. So, we're going to continue exploring Wan 2.1 VACE locally with ComfyUI, focusing on the update of the 14B model and how it differs from other AI models. As you can see in my video demo here, I also posted this video's demo showing various functions you can use with VACE, like swapping objects or first and last frames, like this one. You can also mask objects for video editing. Basically, you mask an area and then you get the output video that matches your reference image for the masked region. We also have video inpainting and outpainting just like what you see here. On the left is the first video, and then I outpainted this one using the lower part of the character's body with the outpaint area. Or take a TikTok dance video with portrait dimensions, you can create a landscape dimension with that as well. So in the Wan video wrapper, make sure you have the latest version of the video wrapper if you're running Wan 2.1, usually in the wrapper custom nodes before. Or you can try out Wan 2.1 VACE with the ComfyUI native node. Make sure again you have the latest version of ComfyUI, as well as for both methods, Video Wrapper and ComfyUI, make sure to update them. The native nodes, as I can see here, are the most doable way, or the way they're using as an example in their ComfyUI blog post, is video to video editing, where you use ControlNet and Pose or a depth map mixed with the reference image to generate the video with motion as the video output here. Yes, we can do that as well for the native nodes and the Wan video wrapper, and I'm going to continue with the Wan video wrapper this time because I have those previous examples of tutorials talking about referencing videos like this workflow or the reference ControlNet, where we're using a similar concept like the Comfy blog post that mentions video to video, and then we have the ControlNet as the pose. I've simplified this workflow to be easier to understand, and then I tried masking video objects and also created what you just saw in this demo video that I've showed. So fears of boxing movements transform into a woman and then a robot. Also the walking motions, like this. And then we transform into another character as well as masking the character on the street walking. We did several of those examples in the demo video, so I thought, why don't we just move all these Wan VA features into one workflow? So I combined those 5 fundamental features and put them all into one workflow like this. It works well and is also able to run independently for each feature. And it's good timing because in the previous video, I talked about the 2 new fine-tuned models based on Wan 2.1. The first one was talking about CauseVid, which is able to run with very low sampling steps. You can still have fair video generation. And the second one I was talking about was VideoGen 1.1. They were first released with the text-to-video model weight type. A lot of people think, well, why don't we have an image-to-video model? That would be more useful for video generation. But it's not quite true when we talk about using the Wan VACE. Let's zoom into the workflow here when we talk about using Wan VACE. Right now we have the new 14B model. This model, the Wan VACE, as we ran the 1.3B preview before, is also using the text-to-video model weights from the Wan 2.1 VACE model. So the Wan 2.1 VACE model is the foundational model for their add-on features, like AI models such as VACE and other LoRa models. You can collaborate with the foundational model, and the text-to-video is the way to use VA. So it's really good timing that we have those 2 models, MovieGen as a fine-tune of V8 for cinematic scenes, and then also we have CauseVid, which runs with low sampling steps. Again, both are text-to-video models. This way we can leverage the text-to-video model type using VACE as their video editing tool. But then we get the base model, Whether you're using the Wan 2.1 14B text-to-video base model, or you can use the Wan 2.1 fine-tuned model MoviGen 1.1. This is also a text-to-video model that's able to run with the new release of the VACE model. Now, the 14B is going to be the one I'm going to use today because it's way better when you see those generated results compared to the previously released 1.3 billion size preview model. Those are not even close in quality. For example, this mask object and swapping objects in the video. It's way more detailed than the 1.3B preview model, as well as the other lightweight 1.3B model that was recently released at the same time as the 14B. Of course, the 14B will cost a lot of computing power and generation time. So last time we talked about CosVid, and it has the LoRa model. Well, the last video I tested was the LoRa models, which are 1.3 billion, very small size models, and sometimes not even able to generate clear pictures. And the CosVid 14B, which I'm just displaying on this screen with the 14B text-to-video, that is compatible. So MovieGen and CosVid text-to-video can be used in conjunction with VACE as a video editing tool. So I think these two fine-tuned models will come at the perfect time when both VA and the 14B are released. Both fine-tuned models train using the 14B Wan 2.1. As a result, our video editing generated videos will be even better quality later on. So again, for the Wan video model loader, either way works. You can use the Video MovieGen 1.1, which is also based on the 14B text-to-video models from Wan 2.1, or you can use the original base models of Wan 2.1 text-to-video 14B. This way, it also works, of course. So we're going to try that out as well. The first thing is that I've put this model loader group here. Then we have the block swap and also the torch compile, which if you have Visual Studio C++, you can use this. Otherwise, you can disconnect or bypass this custom node and also the Sage attentions. If you have installed that successfully for Windows users, then use that. Otherwise, use the SDPA attention mode. Either way works. But it doesn't really matter for the generation speed because we have the CosVid LoRa model right now to help us lower our sampling steps and also lower the generation time. It's faster than before, a lot compared with a normal 14B video model. So the next thing is the video settings. We've got to set the dimensions, width, and height, and also the video length. The default video length is 81 for Wan 2.1. So we're going to try 81 for most of the VACE groups of different features here. So the first one is the reference to video. Now, as you have this group bypass, you can click the reference to video enable, and then we're going to disable the rest of the features at this moment. So always turn the model loader on and the video setting on, and then choose either one of the features below on this list. We got the reference to video on here. Let's say we have this example. We have a lady and then a cake. Let's say, well, this lady character, we've already created some examples before in my demo video, so let's not get boring with one character. Let's find another character to try that out. Let's say this time I'll use my AI character as one of the examples here, another AI character, and then we're going to have text prompts here. Just describe what kind of objects appear. So this time it's her birthday, and then we're going to prepare this birthday cake for her. Let's try this out with this workflow. Focusing on this reference to video group using the new VACE 14 billion parameter models and also the Wan text to video with 14B as well, and I'll show you how that generation runs and the speed later. And we got our generated video. So we have a character that looks very much like the character I referenced, but this time the rose kick for the birthday is a little bit off and different. This time we can try what we can do if we really want. That one is changing the seed number. So from the traditional lucky numbers of Chinese, let's try to make it 777. This is another lucky number of mine, and we'll see if this works or not. But, by the way, before we try another generation, we're going to check how fast this one is this time. So we got the command prompt window running, and then as you can see, when I drag on top of the screen here, we got the first sampling steps. And then this is the next 6 steps that we're actually running the sampler that it's using. It took 1 minute, 41 seconds, and used just about 14 to 16 gigabytes of RAM. This way, because I'm using 6 steps here and using CauseVid, which I showed in the previous video, CauseVid did take action and bring the video sampling way faster than what we usually have with the Wan video. Even the VACE 1.3B has. Well, now we're using the 14B, but then the generation times are similar to the 1.3B right now, and the CFG and shift numbers. So far, I've tested using CauseVid LoRa. I've tried it starting from CFG5, and it's kind of not really following through with the speed of generations with CostV. And also, it doesn't really take part in the generation process, just the way it is. When I set this CFG to 2, that's when I started realizing that it does take effect in the generation time. When I see that, well, it's not as fast as 1 or 2 minutes at that moment, but then I see that it's really taking effect, that the generation time is a lot faster when it loads the CauseVid 14B LoRa model. So I tried it way down to CFG1. It really works the way it is. So I've taken this as the default setting so far for CauseVid. Well, because in CauseVid, when you check, like really checking the theories and descriptions on the page, it doesn't show what the sampling method or the CFG default values they're using, even in the inferencing settings. So the way it is doing is just testing a bunch of settings by myself, and maybe other AI users are trying that as well. So this is what I came out with. So with the sampling step 3, which works, but I tend to set it a little bit higher so it gets more detail quality as well. Even I set the sampling step to 8. It works within the 2-minute mark of time, generating 81 frames. So this is how this works, and let's try out these seed numbers to get the perfect birthday cake with a rose on top of that. And the second gen, we got the rose on top of the kick. Similar shape of kick, but doesn't have much detail with the leaves like the one that I'm showing here. One of the previous examples that I did has a perfect kick, which is here that I've shown in the demo video, and it did really nicely done on how it can replicate the rose and those leaf decorations on top of the kick. So let's move on to other features without sticking too much time on the reference to image, because we've got other 4 features we need to talk about here. The next is the ControlNet Pose as a reference, and we need to play around with this, which again, we have the video for referencing, and then we need an image for reference. This time, I have a character. Let's switch to another character, because this is already done in the video demo intro. So we're gonna have Wonder Woman this time, so more easily recognizable for everyone. And this is kind of challenging for the AI video because we have the costume, the outfit of this, and then I generated it already. Meanwhile, we have this appear. Well, the textures aren't there. Maybe this is because of the text prompts that I have and less enhancement for the outfit texture. I will try more detail on the text prompt and see what it gets. But so far, we have the style, the hairstyle, and the pattern of the costume able to replicate with the reference video. Let's try out with vision language models to have more text prompt enhancements with this image, and I've added more text prompts based on the basic text prompt that I had in the first example. And here, of course, the text prompt I was using the ecosystem of Alibaba AI models, which this time is using Wan 2.5 Max. It has the language and vision model in one. So it gives me this text prompt. I put that on the VA text prompt, work on the workflow, and we got more texture, and the outfit of the costume of Wonder Woman looks more like the reference image that I have here, which looks pretty good this time. And the styles and everything are more coherent, as you can see, compared with before in the 1.3B preview model. All the backgrounds as well are able to replicate with what we have, as well as the shape. And then the character in here is obviously way better, more detailed than what we had before in 1.3B. And this time, because of, I haven't mentioned the backgrounds, or I've removed the background, so therefore, it's using what is based on depth anything v2 based on the shape of the background. And we have replicated those shapes for the concrete wall and some windows as well. So moving on to the next examples, which I have the first and last frames. This one is more interesting here. I've tried that with 2 images and is able to stitch these 2 unrelated images, or the pose is not even close. Of course, it's the same character, but then different camera views and different positive poses. A lot of big differences between the first and last frames. It's able to create this animation of this video really smoothly without, unlike other first and last frames or frame interpolations AI that did a lot of morphing and broken parts of each object in between those two start and end frames, very smooth transitions even with different camera angles. Usually, we see this kind of smooth transition with frame interpolations that only a small part of the frames are different and able to do very smoothly. But then this one has a different camera view, the pose of the character is different, and we're able to transit that very smoothly. And I see this one is even better than the first last frame AI models from Wan 2.1 released previously. I think we don't need to keep that model instead of, we just need to use VACE 14B, which is good enough to have these features included. So it's using the Wan video VA start and end frames notes. Through that, we're going to pass the input frames as well as the reference image. The reference image is coming from the V2 of the start frames. And then using the start frames as the reference image and input frames. Here, we will have masking the different numbers of frames. And then we have the start frames and the end frames here, and also, as well as the mask, this one is also able to use in the CosVid LoRa for lower sampling steps. Just think of this way, low sampling steps. Like previously in SD 1.5 or SDXL, we have the LCM or the turbo of LoRa models we can use, like, few step samplings to generate an image. But after a year, in 2025, we can use few steps of sampling to generate a video. How amazing is that? And this time, I've tried something way different. First, I will have futuristic styles of women controlling a computer, and everything of the theme is futuristic. And then the next image I will use is in the same futuristic style with Python. And the Python is more like a robotic feeling. You see the texture of that. So we're going to transform, like do a little morphing style transformation of the woman transforming into a Python. And then I have the masking here. I want to demo and show you guys what I just talked about in the masking section. So when we have the VA start to end frames here, when we load the start frame and end frame, we have the mask here. Also, you can use the control image if you have specific ControlNet Pose for referencing. And here we have the start frame, end frame. Between those frame durations, it will be letting the AI do its own creativity, which is starting from here. And then it will eventually transform into a snake. This is more abstract style transformation this time, not like the previous examples that I have of a woman with realistic styles, the same character, which I feel a little bit boring. We're going to be more abstract with transformations. And here I have generated the result. And of course, this is not always going to be good. Like this example, suddenly the snake doesn't do the body transformation from the woman. And I did another one previously, which is here, generated a few times with these combinations of images. And this one, it did transform into the snake from the woman here. And then, because of the supercomputer flash that triggered this effect, it's able to go through transformations. And of course, if you have the same character like this, then it will be easier for the AI to do frame interpolations like this. Either way, lots of people will use that for AI video. And the morphing styles like this will also be used for AI video. Lots of effects like this, it's up to you which way you're using, but then this one works. And the first last frame interpolation using VACE is a lot smoother than the fun Alibaba PAL1 fun model series, and also the first last frames from Wan 2.1 as well. I think just using this one is good enough for this kind of first last frame video. Next, we're going to try VACE mask editing. Now, this one has lots of different methods to play with for mask editing, where we have the character or any objects in the video. For example, here we have a female. She's practicing kickboxing and kind of styles like here on the ring. And anyhow, we will be animating this and transforming into another character. Very typical way of using mask editing in video. Previously, in the 1 VACE 1.3 billion, which you will see a lot of generated videos losing the video's quality. But when we're talking about the 14B, it's way better. You see the first on the top is the source video. We got the mask video, and then we got the generated video on the bottom. And then another example is here. We got the mass region transformed into a robot that we can do and animate with this, like using this workflow feature for VACE. And this time, because of in-paint masking, I have not used the LoRa for CostV in this group for mass editing. I have dedicated a LoRa loader here, which is not going to be using the same shared LoRa loader in this workflow on the top of this group. Whereas you can see this is way different when we have CostV. And by the way, the average time of the generations that I did in the previous two examples, so about the range of 81 frames, is about that range. Using 1 minute 41 seconds for me using NVIDIA 4090, and maybe you can get even faster generation time with higher end or higher models than my HobbyTube computer using NVIDIA 4090. It's up to you to choose. Anyway, back to the workflow here. So we're going to try the mask editing and we're going to run this. This time, I've also added the video upscale with models. Now, this is another custom node because of mask inpainting of the video. I want to add the details as well as upscale the video resolutions. So in this way, I will be using a normal sampling step 20 and the CFG using normal 6 and the shift using 5, or sometimes you can use 6 as well for the shift, whichever way you want to try. Scheduler, I will use the DPM because this is going to be more creative for the AI. And here, as you can see, I have not connected any LoRa models, so by doing that, I'm also going to change the Wan 2.1 this time and want to test out with the MovieGen 1.1 FP8 model. This one is going to use the quantized FP8 models here. And then we're going to try that out. So once I click generate, and you will see that here I got this image. And then this is going to be animating this character looking like a futuristic robot with silver armor, like the image that's showing here. And we're basically using segment anything to mask for the masking. We get a mask blur just like the old way that we do masking. Put that mask area region into the source video. We blend that into a whole set of video for our input frames. And then the reference image, of course, is going to be our image for the robotic futuristic robot here. So here's the generated result as the input of this reference image. We have generated the result here. And this is a small dimension. After that, I use the 2x upscaler here. And we got the generated result higher resolution, which we can take a full preview look of this one. It upscaled it very fast easily in this node. Through these, I have the frame width and the frame height of this one, double the size of the resolutions that I have set for the width and height here. So obviously, the detail of the robot, everything, the armory, and lightning energy going on the body part is getting from this image very close to the style, as well as you see the hammer on the hand here. And then we also have this hammer following up on the hands here becomes the boxing gloves. And this looks pretty cool this time, the masking regions here. I tend to expand the mask more this time, so it gives a little more freedom with low space, extra space for the robot. You got the horn on the helmet and as well as the big gloves representing using the hammer for that. The 14B text-to-video and also the VACE 14B do a lot better getting more details, especially using the mass editing. This kind of in-painting method, you need higher details for the rendering. So, this is why I did not use the CosVLoRa model this time. I just used the full model of how it renders with the normal 20 steps for the demo. This was using above the 5-minute marks to generate this style of video. And the next one is the outpainting. This is obviously getting different dimensions. And then we can create like these examples here. I have a TikTok dance video from a popping dancer. Then I have outpainted this area for the other content that will be generated through the AI. And from here, we got the input reference of the mask and then the input frames. We do video-to-video editing for this one. So therefore, all the content within the first source video frames are going to happen as well. But then we will be outpainting the other part that is padded by this group. The white color regions, we have transformed it to the background of what it is in this source video. And as well as here, we do the upscaling for video upscale here. Therefore, we got this landscape ratio of video right now other than the portrait styles like TikTok video dimensions. So therefore, this looks pretty realistic. Even you see in between this area, it should be having this place that is actual from the video source and then the generating content from the AI, and the stitching part for the background is pretty nice on this one. So yeah, check this out. The VACE 14B, previously this workflow has been posted on the weekend since I completely finished it. I posted it in my Patreon groups, and subscribers over there and supporters in my Patreon groups noticed and downloaded it. They've played around with that for quite a time. And I was, just happy that everyone shares it for everyone to try on the 14B VACE model, because it's way better than the 1.3B previous versions in that VACE launch. And then I put all 5 fundamental features of VACE together into one workflow and just wanted to share this to everyone. Of course, there will be more advanced styles of workflow design if you want to deal with more advanced features or even more customizable for your own work. And that way, you will need to be more creative yourself to mix and match with different features. I try to put things more modularity for different features of usage. So just modify the input-output of what it is merging with your own creativity of workflow. It works as well. So that's it for this video, and I'll see you guys on the next one. Let me know what you think, which features you are using the most with VACE, and something that you feel wow about in this version of the 14B model. I'll see you guys on the next video. Have a nice day. See ya!